All right, so now we're going to continue working with scatter plots, and there are some more real-life situations. The goal of doing all these scatter plots will be to find the line of best fit. So we need to find the line of best fit, meaning we want to find the average. If we were to take all of our points on our graph or on our table and we put them on a graph, where would the line go? Meaning it's going to be right in the middle of all my data and it would represent the average, or I can make predictions about the future or about some numbers in between if I knew where the line of best fit was. So let's go ahead and take a look here at our graph. Okay, so we have meal cost and tip. Again, meal cost is up there, so I'm going to call that X and tip will be Y. So we'll say that meal cost is down here, and we'll say tip is right here. Tip. Okay, so there's meal cost and tip. And so what I'm going to do is I'm going to put all of I first have to decide how I want to label the lines. So I have all my lines here on the graph, but we have to decide which line is going to be worth. And we also need to decide, do I need to start at 0, or can I maybe start a little bit later and then go by as a number system there. So meal cost, X. My lowest cost, it seems as if it's right there, $4.75. Seems my smallest cost, my biggest cost is $20.42. So it starts at $4.75, goes to $20.42. And so let's see. So 4, if I started at 4, that'd be good. And it goes all the way up to 20. And I know 4 is a factor of 20, so if I went by 4s all the way up, I should be able to graph this pretty well. So let's do this. I'm going to do 4, and I'm actually going to go by 2, so there's actually 6 there. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I actually went by 2s that time. And again, I don't have to label every line. You can if you want. Like I can do 6, 8, 10, 12, 14, 16, 18, 20, 22. But you don't have to label every line. All right, let's do the same for the tip. My smallest tip, it seems to be 50 cents. And my biggest tip is $3. So on my graph, on the y-axis, let's go ahead and label our tips by 50-cent increments. Why not? So again, we'll do 50 cents here. So that means this line's $1. We'll just do $1.50 here. That means this is $2. That means this is $2.50. That's 3, 3.50, 4. Okay. So again, I didn't have to label every line. I just know I have a pattern of 50 cents going up and down. Okay, so now what I'm going to do is put all of my points on the graph, and I'll go ahead and speed that up real quick for us. Okay, so there are all my dots on the graph. And again, you can see that there's some sort of pattern, right? You can see that it's a positive correlation. And what this graph is telling me that the higher my meal cost is, meaning if it was higher cost in the meal, the more tip that you expect to weight down, or how much the waiter should expect to receive. So notice that there is a positive correlation. And again, if I were to draw my line, again, I have a fancy piece of technology, so it should be able to do that nice for me here. Again, it looks like if I did just that, it looks like it's going to pass through right in the middle. Notice how it kind of has, it goes through one of the points, has some points above, some points below, but it looks like it's right in the middle of all those lines. So I'm going to put a dot here because now I need to find the equation for the line of best fit. And for an equation, we talked about this last unit, the equations we need. Again, it's usually y equals mx plus b. The two things I need to find: slope, y-intercept. Okay? Now, there's two different ways to do the slope in these problems. Now, because we have a nice graph with the grid lines, we could count, again, rise over run. We find the two spots. Again, we want to find 2 points on the graph where we know that cross exactly in the 4 corners of the boxes. Again, we want a spot on the graph that crosses perfectly in the 4 corners of the graph, like right here. Notice how the line goes perfectly through that. So I'm going to put a dot right there. And then it looks like right here again. So again, remember, see how it crosses right through the corners of the boxes. So I can find the slope between those 2 points, or I can actually find the coordinates of those 2 points. So for example, if I were to write This is at 12 comma, it looks like 150. So 12 comma 150. And then here, it's at 18 comma 250. So there's two different ways you can find it. You can do it by counting, or you can do it by using the slope formula. So remember, the slope formula is y2 minus y1 over x2 minus x1. Okay? So, and remember, if you do it by counting, remember each line that you go up is 50 cents, and each line that you go to the right or the left is worth 2. So if I were to do the counting method, it would go up 1, 2, or $1. So it goes up 1 over, again, it goes by 2's going to the right, so 2, 4, 6. So my slope in this case would be 1/6. Because again, going up and down, each line is worth 50 cents, or 0.5, which I went up 2, so it's 1. And then going to the right, each line is worth 2, and I went over to the right 3 times, so 2 times 3 is 6. You can also do it by the formula. Again, if I were to do it by the formula, it would look like this. So y2 is 250 minus y1, which is 150, over x2 is 18, x1 is 12. 250 minus 150 does equal 1. 8 minus 12 equals 6. So either way you do it, it's going to work out where the slope should be the same. But remember the couple key points. When you find the slope, you have to pick points that are on your line. I couldn't pick the green point up here. In fact, let me circle it. I couldn't pick this point right here because it's not on the line. And some of the points you may pick may not be on the line. And so as long as you make your line, you can pick your own points. And as long as those points are on the line, and again, those points are on the exact corners of 4 boxes, it makes it real easy to find the slope. Okay, so my slope is 1/6. I found it 2 different ways. The next thing I need to find is B. So let's find B. Now, B stands for y-intercept, and again, that means where does my line cross the y-axis? Well, it's right where I put this green dot, which is actually at 0, according to my graph, so B equals 0. All right, so now that I have my slope and my y-intercept, I can say that y equals m is 1/6 x, and then b is 0, so I don't need to put that. So that is the equation of my scatter plot here and the line of best fit. So using that, we can answer the question. Again, if the diner orders a meal costing $10.50, so let's come to my graph over here. So $10.50 would be about here. Again, not halfway in between, but just under half. So $10.50. How much tips should the waiter expect to receive? So you can draw a line to your best fit right there, and then come across here. And again, it looks like it would be somewhere around, again, it's between $1 and $1.50, so I'd say $1.25. So $1.25 should be the tip. Or you could plug it in to your equation that you just made. So you would get y equals 1/6 times, and again, $10.50. So 10.50 over 1. Again, you can multiply straight across. So it would be 1050 divided by 6. And again, if we had our calculator out, 1050 divided by 6 would give you 1.75. So again, the equation is obviously a lot better because it's obviously a lot more exact. But looking at the graph, it'd be somewhere around, again, that actually sounds pretty accurate, so 1.75. So anyway, that is how you find the line of best fit, the equation, and then you use it to make predictions.